There's a version of this story where you never hear the warning, not because the systems failed to detect it, but because from the moment of launch to the moment of impact, you had 4 minutes and 51 seconds. Not enough time to call your family, not enough time to reach a basement, barely enough time to understand what you were looking at on your phone. This is not a Hollywood scenario. This is a physics problem, and the physics does not negotiate. To maintain your clearance for future threat assessments, verify your subscription to the Last Day Theory. And to support independent, unclassified defense analysis, consider joining our strategic command roster. The link is below. Now, let's examine the gap. The North Atlantic is not empty. It hasn't been since 1949. Woven across its floor, at depths that crush steel like paper, lies a network of hydrophone arrays. The Sound Surveillance System, SOSUS, a Cold War architecture of passive listening posts, anchored to seamounts and continental shelves, designed to hear a Soviet submarine from 600 miles away. It heard everything: propeller blade frequencies, engine harmonics, the biological noise of a crew breathing, moving, existing. For 40 years, it worked. Soviet submarines were tracked from the moment they left port. Files were maintained, patterns were studied. The ocean, for all its enormity, had been made transparent. Then the Yasen-M entered service, Russia's Yasen-M class attack submarine. NATO designation Severodvinsk is not an evolutionary improvement. It is a generational leap. Its pump jet propulsor does not cavitate the way a traditional propeller does. There is no blade slap frequency for SOSUS to classify. It's a anechoic tile coating, rubberized acoustic dampening bonded to the outer hull, absorbs active sonar pings rather than returning them. Its reactor operates on a natural circulation loop at low speeds, eliminating the primary coolant pump noise that gave away every previous Soviet design. The Yasen-M doesn't sneak past SOSUS by going faster. It sneaks past by going quieter than the ambient noise of the ocean itself. Our scenario begins here. Classified position: North Atlantic, 500 nautical miles east of Washington, D.C. The submarine is at periscope depth. It has received its targeting package via an ELF, extremely low frequency, signal from a transmitter buried in the Ural foothills. The crew does not discuss what the target is. They don't need to. The coordinates are loaded. The weapon is a 3M22 Zircon, NATO designation, SSBN-33, a hypersonic cruise missile. It sits in a vertical launch cell in the bow of the submarine, directly behind the sonar sphere. The cell is pressurized. The launch sequence takes approximately 90 seconds from authorization to ignition. At 0317, Zulu, the Zircon, leaves the water. The clock starts at Otis Air National Guard Base on Cape Cod, Massachusetts. Two enormous AN/FPS-132 PAVE PAWS radar arrays face the Atlantic and the Arctic. These are phased array radars. They emit no moving parts, no rotating dish. Instead, thousands of individual transmit/receive modules fire electronically steered beams across an enormous volume of sky simultaneously. They are designed to detect ballistic missile re-entry vehicles at ranges exceeding 3,000 miles. They are extraordinarily good at their job. 12 seconds after launch, PAVE PAWS has a track. What PAVE PAWS sees in the next 60 seconds is not what the system was designed to handle. A standard ballistic missile, an ICBM, exits the atmosphere. It reaches apogee at altitudes above 1,200 kilometers. It follows a clean, predictable Keplerian arc. Geometry does the work. The fire control solution is elegant. The Zircon does something different. The Zircon is a scramjet vehicle, a supersonic combustion ramjet. Understanding what that means is understanding why it cannot be stopped. A conventional jet engine compresses incoming air with rotating fan blades, then ignites fuel in that compressed air. This works up to approximately Mach 3. Beyond that, The fan blades themselves become the problem. They cannot spin fast enough to function, and the aerodynamic heating they generate becomes catastrophic. A ramjet eliminates the fan entirely. It uses the vehicle's own velocity to compress incoming air. The faster you go, the more compression you get. This works from roughly Mach 3 to Mach 6. A scramjet, supersonic combustion ramjet, takes this further. The airflow through the combustion chamber remains supersonic throughout. The engineering challenge is extraordinary. You must ignite and sustain combustion in a supersonic airstream, roughly equivalent to lighting a match in a hurricane and keeping it lit. The Zircon is believed to achieve sustained speeds between Mach 8 and Mach 9 in this flight regime. Now here's the physics constraint that defines everything that follows. At sea level, air density is approximately 1.225 kilograms per cubic meter. At Mach 9 in that environment, aerodynamic heating from skin friction would generate surface temperatures exceeding 3,000 degrees Celsius. That is hotter than the melting point of tungsten. No known structural material survives that in sustained flight. This is why the Zircon does not skim the ocean. Hollywood gets this wrong. Physics is absolute. At 30 kilometers altitude, the stratosphere, air density is less than 2% of what it is at sea level. In that near vacuum, a body moving at Mach 9 generates surface temperatures that advanced thermal protection systems can barely survive. The missile's nose cone and leading edges are constructed from carbon-carbon composite materials, the same class of material used on space shuttle leading edges, capable of withstanding these temperatures for the brief duration of the flight. The Zircon does not fly where it cannot survive. It climbs to where the physics allows. From launch point 500 nautical miles offshore, at Mach 9 in the stratosphere, it reaches the coast of Virginia in approximately 4 minutes. Washington, D.C., is another 3 minutes inland at lower altitude as the missile descends for terminal phase. Total flight time, approximately 7 minutes. PAVE PAWS, detected it at T+12 seconds. The warning window is 6 minutes and 48 seconds. The United States Ground-Based Mid-Course Defense System, GMD, is the only missile defense layer designed to intercept a nuclear warhead before it reaches American soil. 44 ground-based interceptors sit in hardened silos at Fort Greely, Alaska, and Vandenberg Space Force Base, California. The interceptors are large, they are fast, they are exo-atmospheric. They kill their targets in space, above the atmosphere, during the mid-course phase of a ballistic missile trajectory. They are completely useless here. GMD is designed to kill objects above 100 kilometers altitude. The Zircon never exceeds 32. The interceptors cannot be depressed into the atmosphere. The physics of their kill vehicle guidance systems and terminal seekers are optimized for the vacuum of space and the infrared signature of a re-entry vehicle in exo-atmosphere. So what about THAAD? Terminal High Altitude Area Defense. Maximum intercept altitude, approximately 150 kilometers. But its minimum intercept altitude is constrained by engagement geometry. The radar track must be stable, the closure time sufficient, the look angle workable, against a target moving at Mach 9, with a total flight time under 8 minutes and a terminal descent phase of approximately 90 seconds. THAAD has, at best, 1 shot, likely less. AC-3 Patriot operates in the lower atmosphere, engagements below 40 kilometers. In terminal phase, the Zircon descends from 30 kilometers to target in approximately 60 seconds, shedding speed to the low supersonic range. But the radar cross-section of a hypersonic vehicle in terminal dive with a plasma sheath partially disrupting radar returns gives Patriot fire control perhaps 30 seconds of valid track data. The probability of kill against this specific target profile is not published.
Unclassified analyses suggest it is not high. This is the engagement gap. The Zircon was engineered to occupy it. It is not a flaw in American defense procurement. It is a deliberate architectural vulnerability studied by Russian weapons designers over decades. The GMD shield exists above the missile. The lower-tier defenses exist below the regime where this weapon achieves its performance. The Zircon, in this scenario, flies between them. The shield is not just shattered, it was never built to cover this seam.
At 0317, Zulu, PAVE PAWS achieves initial track. The data feeds to the 21st Space Wing at Peterson Space Force Base, Colorado. It flows to U.S. Northern Command, also at Peterson. It arrives simultaneously at the National Military Command Center, the War Room, inside the Pentagon. The senior controller picks up a phone. The notification chain is not a decision. It is a protocol. It executes itself. T+40 seconds. NORAD commander is notified. Preliminary missile event conference call initiated. Connecting NORAD, U.S. Northcom, Strategic Command, the Pentagon, and the White House Situation Room. T+90 seconds. The intelligence is assessed. Track is consistent with a launch from the North Atlantic. Trajectory indicates Washington, D.C., or surrounding high-value targets. Warhead status unknown, assumed nuclear. T+2 minutes. The President receives notification from the White House Military Office. The Presidential Emergency Satchel, the football, is opened. The President is presented with options. The biscuit, a card containing the authentication codes, is verified. There is no Hollywood moment here. There is no argument and no last-minute heroism, no ethical debate in a fluorescent-lit room. The system was designed to function faster than human hesitation. The President's role at this point is authentication, not deliberation. The deliberation happened decades ago, in classified basements, by men who understood exactly what they were building and why. The decision tree for retaliation was made before this President was born. The E-6B Mercury, designation Tacamo, take charge and move out. This aircraft is the last link between a living command authority and the submarines that carry America's second strike nuclear force. It exists because planners understood, from the earliest days of the nuclear age, that Washington, D.C. might not survive long enough to issue a retaliatory order through conventional channels. The E-6B carries a VLF, very low-frequency, communications system. The critical component is its trailing wire antenna, a 5-mile-long copper wire that unreels from a drum in the aircraft's tail during transmission operations. The aircraft flies in a tight orbit. The wire hangs nearly vertically below it, dragged into position by a drogue weight. Very low-frequency signals, in the 3 to 30 kilohertz range, have a unique physical property. They penetrate seawater. Not deeply. A submarine must be at shallow operating depth, approximately 60 feet, to receive them clearly. But they penetrate. No other practical communications medium does this. The emergency action message, the EAM, is a formatted, encrypted message. It is short. It contains authentication codes. It tells the submarine crew that a valid launch order has been issued by a properly authenticated command authority. At T+4 minutes and 30 seconds, the E-6B over the Atlantic begins transmitting. The 5-mile wire unspoils into the dark air. At T+6 minutes, 22 seconds after launch, the Zircon completes its stratospheric cruise phase and pitches nose down into terminal descent. It is now subsonic. The plasma sheath has dissipated. The warhead, estimated yield in the low to medium kiloton range for a tactical nuclear variant. Arms. There is no impact footage in this documentary. There will not. The detonation occurs at approximately 500 meters altitude above the target. Airburst configuration maximizes the ground pressure wave footprint. The electromagnetic pulse from even a low-yield nuclear detonation at that altitude covers a radius of tens of miles. SCIF hardened military systems operating on shielded circuits survive. Commercial infrastructure, the power grid, cell towers, internet exchange points. Every unshielded electronic device within the pulse radius does not. East of the Potomac, the lights go out.
The Ohio-class submarine is arguably the most consequential weapons system in human history, not because of what it does, because of what it prevents. There are 14 Ohio-class SSBNs in the U.S. Navy's Strategic Deterrent Force. At any given moment, a significant fraction of them are at sea, on patrol, unreachable, untrackable, alive. Each one carries 24 Trident 2D5 missiles. The Trident 2D5 ballistic missile has been in service since 1990 and remains, by virtually every unclassified metric, the most accurate submarine-launched ballistic missile ever built. Its circular error probable, the radius within which 50% of its warheads will land, is estimated at 90 meters at intercontinental range. Each missile can carry up to 8 independently targetable re-entry vehicles, MIRVs. Each re-entry vehicle carries a W-88 thermonuclear warhead with a yield of approximately 475 kilotons, or a W-76 variant at approximately 100 kilotons. One submarine, 24 missiles, up to 192 warheads. The yield of a single W-88 is approximately 30 times the yield of the weapon that destroyed Hiroshima. The emergency action message arrives. The crew has trained for this moment thousands of times. In drills, there is always the unspoken knowledge that it is a drill. There are procedural tells, small anomalies that experienced crew members learn to recognize. This message has none of them. The authentication process requires 2 officers to independently verify the message against their personal authentication documents. A 2-man rule. No single individual, regardless of rank, can initiate a launch. Both must authenticate. Both must act.
The captain orders the submarine to launch depth. The boat angles upward. The Trident II launches via a gas steam ejection system, a cold launch. Compressed gas propels the missile from its tube and clear of the water before the first stage solid rocket motor ignites. This protects the submarine from the motor's exhaust plume. The missile breaches the surface, motor igniting at approximately 30 meters altitude. Then the second, the third, a full salvo. The Trident II follows a depressed or standard trajectory, depending on targeting parameters. At standard trajectory, it reaches apogee above the atmosphere, where the GMD system was designed to operate, and distributes its re-entry vehicles across an independently programmed target set. Flight time from North Atlantic launch position to targets inside Russia, approximately 15 to 20 minutes. The post-boost vehicle, the bus, maneuvers between warhead releases, delivering each re-entry vehicle to its precise ballistic trajectory. There is no missile defense system on Earth that can intercept a coordinated SLBM salvo from multiple submarines at scale. This is not speculation. It is the foundational conclusion of every serious strategic analysis conducted in the last 40 years. This is the doctrine of mutual assured destruction, MAD. It is not a warfighting strategy. It is a suicide pact with geopolitical characteristics. Its logic is simple to state and almost impossible to fully internalize. If you strike first, you die second, and you die completely. The doctrine has held in some form for 75 years, not because humanity became wiser, but because the physics of nuclear weapons made the arithmetic undeniable. A Yasen-M class submarine exists. The 3M-22 Zircon hypersonic missile exists and has been operationally deployed. The engagement gap in American missile defense architecture is documented in unclassified congressional testimony and open-source defense analysis. The E-6B Mercury is airborne on continuous rotation. The Ohio-class submarines are at sea. None of this is speculation. What is speculative, what every defense planner in every serious government hopes remains speculative, is the decision to begin. The shield has gaps. The deterrent endures. The difference between those two facts is the entire history of the world since 1945. And it holds for now by the margin of a choice no one has yet made. Producing this level of unclassified, objective defense analysis requires weeks of research and rendering. We do not accept corporate or political sponsorships. We rely entirely on you. If this briefing brought you value, leave a super thanks or hit the join button to become an elite member of the Last Day Theory. Until the next assessment, stay vigilant.